Ashik Appanna, Head of Key Accounts at Carl Zeiss India. Industrial Quality Solutions bring in over a decade and a half experience in manufacturing industry, and is engaging in providing solutions to clients in various industry segments of industrial metrology. Mr. Appanna is a member of Global Aerospace Strategy at Carl Zeiss and has expertise in providing turnkey solutions with focus on technology. Mr. Ashik will deliver highlights about aerospace technology along with component-specific measurement challenges and solution, and will talk about the latest trends in measurement technology. Let's welcome Mr. Appanna.
Thank you. First of all, good evening to all of you, and thanks OEM Update for organizing this session. Definitely, so far it's been quite interesting. Here, I'd just like to be presenting on some key components on the aerospace sector. First of all, the previous presenter, Mr. Piyush, spoke a lot about manufacturing, design, and all these things. You know? But what is important between these two is between a designer and manufacturer also is one sector group is called the metrology department, the measurements. So what you manufacture, you need to measure, and based on the feedback of measurements, you need to see how you proceed further. So this gives me an excellent platform to continue. Once you have manufacturing, then you have measurements, which is one of the most important criteria. And just on the introduction on the aerospace industry, as you see, aerospace industry generally is categorized in three ways. You have commercial, defense, and space, as we all know. There's also a fourth one, which is MRO, where measurements are important, but it doesn't take so much of lag as these three industries. But when you have these three industries, what's common in these three industries is, there are certain set of parts. These are very common. Aerostructures, propulsion systems, services, all these things are common. Most of the parts are there. These are manufactured parts either by in-house people or the main OEMs outsource it to different countries to find good type of vendors. Now, these are very critical and require 100% inspection. So as we know, in aircraft components or in aerospace industry, anything you manufacture should be measured 100% and also should be traceable for any future traceable at the customer's end for any future problems to be found out. So coming to this, when certain parts are manufactured, each part has a certain way for measurements. For example, I've just chosen blades, which are coming on to you. Blade measurements. These as you see, is a cross-sectional view of a jet engine, and you have different stages where each stage has blades, and each blades play a very important role in generating power, which is really mandatory. And the quality of these blades should be very good, as you all know, because any drop in problems can result in lesser energy. So to take the output of maximum energy, so your measurements should be in line with your design criteria. You have different types of blades available in a jet engine. You have metal leading edge, your compressor airfoils, your turbine airfoils, and also bladed rotors. Different types suited for different functions, which is beneficial. So under these, just to give an example, when you manufacture a blade through a supplier, there are certain parameters, the lead, twist angle, the leading edge, trailing edge. All these are very important parameters in functioning of a blade. Now we'll have to see on how do you measure it. This is where we come in, as Zeiss, we come in expertise. These before measurements, as you all know, you need to have fixturing. Fixturing kit is one of the most important thing where before you do measurements. You have certain different sizes depending on the size of the blade. You have these fixtures which are used, and moment you have these fixtures, it can be mounted on a rotary table. You can have a contact-based CMMs which are used, and there are different type of sensors. You have these are called sensors or probettes based on the quality requirements, whether it's accurate, mid-size, medium accuracy, or high accuracy. You can use different type of sensors. For example, you have non-contact sensors. We're using light. You have laser sensors, and also you have contact sensors using probes. And normally, how a final setup looks on a coordinate measuring machine when you're looking at measurements is something like this. You have a separate software, especially for blades and impellers. These are designed with special algorithms suiting each customer requirements. Suppose if a vendor is supplying to Boeing, Airbus, so they have a specific requirements, or even Safran. So we fulfill those requirements for the customer using from the software. And you see one of the methods, you have a very typical coordinate measuring measurement solutions where one system can hold different types of sensors. That all depends on what the customer is manufacturing at his end, whether he's trying to, whether he's looking at a mid-size blade with mid-level accuracy or higher accuracy. Depending on that, we provide solutions. And there's another type of solutions for quick measurements where accuracy is not so important, but you just want to understand the profile of the blade. So we have non-contact 3D scanners which are available, which are automated, which also can be automated, and where every time you don't need an operator's intelligence to get in between to improve your productivity. We have this option. So this is a brief about something about blades. Now, one thing which I really I'm excited always about is the new trends in metrology. We use X-rays. X-ray is one of the latest trend in measurements and processes. Why X-ray? It's the same concept what you use when you go to hospital with a broken bone. To find out how much is broken, where it's broken, you use X-rays. The same concept of machine is brought down in manufacturing today also to check two things. One is to check for internal defects, and second is you can also do metrology part of it. So why X-rays? X-rays are highest energy electromagnetic waves, and they are able to penetrate matter easily. They have the shortest wavelength and higher frequencies, and because of this, you have the penetrable properties. So depending on the material, if you have electronics, it can be easily penetrated. If it's aluminum, it can be easily penetrated. If you have cast iron or really high grade of metals, then you need a longer exposure for it to wavelength, depending on how much power you intend to provide. So if you want to provide, if you want to look at these options are there. There are several options depending on the customer requirement. Suppose the customer only wants to just look at crack. You have a 2D radioscopy machines. If he wants to do a complete analysis to find out how the pores are, where the pores are located in the casting and after machining, what exactly, then you can use computer tomography. And you also have micro X-rays. These are basically very high end, used in research of materials and parts. So normally in the industry, you have the 2D radioscopy and computer tomography, which is quite popular. And field of application can be on anything. You have connectors, batteries, PCBs, powertrain, casting components, casting machines, aerospace blades, and connector housings, light metal parts, even composites. We have proved these kind of solutions for customers. And why CT? CT gives you a full insights about the part, how the part is assembled also, what is the wall thickness and porosity or blowholes. All these can be done. And using the software, once the part has been scanned, CT scanned, you can also conduct metrology analysis, direct CAD comparisons, nominal comparisons, and also defect analysis within the part, whether it's external or internal. There's basically you can use it for process control, excellent process control. And when you have assembly of parts, you can also use it for checking wall thickness analysis, which is really good. And what it overall does is, some of the examples I'm trying to give you, defect analysis when you want to check on assembly control. When you're talking about critical weld joints, you want to check how well the joining has happened in welding. So these are certain fantastic things you can really get things done in using CT technology. And even electronics, PCB board testings. If you want to check for critical assemblies within the part, so you can just put in the part inside the machine, get the X-rays scanned, and then do the analysis using the software. Sometimes you can also detect. If you see the first one, defect analysis 3D, you can actually locate where exactly is the defect, at what plane, what angle, at what coordinates. So that's the beauty of this CT machines. what it overall does is you're able to control your quality better. Suppose you have to have, suppose you would like to improve on how do you say, productivity of your process. This gives you a great example. If you're developing a new product and you want to decrease the product life cycle, product manufacturing cycle, prototype testing, this is one of the best solutions. This is based on my experience, what we have. And after CTE, there's something called optical sensors, wherein this is used for parts which are very feeble, can be plastics, thin plastics, and where you want to have quick measurements of dimensions to be checked. So you have an option of combination of non-contact system as well as a contact system, wherein wherever there is requirement for non-contact, you can use the light, and wherever you have requirement for contact, you can use a standard probe method. Yeah? And how the inspection can look, you can also set it up for 100% inspection, inline inspection. We have the solution for you. Just to give you an output, just to give you this thing how these machines look, I'm just showing you. This machine is brand of machine is called optical inspection. Now, just at the previous slide, we had Mr. Prayers gave about additive manufacturing. So what we are into is, what we do to customers, or what type of solutions what we provide is, we have this Zeiss blue line technology, right from your powder until the part. We give you solutions. Okay, you want to check the material characterization of the powder. Zeiss offers SEM, light microscopy, X-rays, nano X-ray CT solutions. Then if you want to have in-process metrology, we have CMMs for it and 3D scanning for it. And if you want to look at any internal defects in your process or external defects, you directly have you can use X-ray CT tomography system. And final inspection quality when it comes to dimensional and surface quality inspection. So we have a complete range of solution. We have together for in additive manufacturing solutions. We've been successful in quite a few companies, and also we've given apart from additive manufacturing, we've given solutions on to metal injection molding companies also. And one more beauty of it is all the output of these machines, for a part, can be connected digitally. So if a customer wants to know what he has done from right from a starting stage to a finished stage, he can always take the results at one go. So this is what we offer, and this is what we have expertise on. Zeiss not only has expertise in measurements, but also remember, we are the first company to start or invent microscopes. So we have expertise on both sides of the spectrum, and this gives us a great advantage, and also gives a great benefit to customers who are actually looking into total solutions. So the final trend, which is always going along in this industry, is right now, normally people talk only about production on the shop floor. Now there is also production in the quality systems also, how fast you can measure each component. Whether you want to integrate it with a robo in the cell, we are able to do it today in today's technology. Whether you have multiple parts to be measured, you can have a manual or automated loading systems. So which increases the productivity of the machines, and obviously, as you know, decreases the cost for the customer, and always benefits for the both sides. So by this, I think I end my 10-minute session. I hope people have got some brief insights about what Zeiss does.